we know that an atom is electrically neutral. It has positive charges, that is, protons, which are heavy, so they remain attracted the atom, whereas the negative charges, that is, electrons, are very light and remain in a constant random motion around the nucleus. The free electrons of a good conductor of electricity, such as copper, aluminium, etc., start flowing in one direction when connected to a source of electricity. That means when we switch on the bulb or fan, the electricity flowing through the wires is actually the flow of electrons. This flow of electrons, electric charges, through a conductor is known as an electric current. Electric cell as a source of electricity. For the electric current to flow, there has to be a source of electricity, which could be derived from electrochemical cells, solar cells, electric generators, or dynamos. Let us study about an electrical cell to understand electricity better. We use cells in torches, watches, calculators, toys, etc. If you look at the cell carefully, you will find certain marking on it. On one side of the cell, there is a positive sign, and on the other side, you will find a negative sign. Hence, a cell has two terminals, a positive and a negative terminal. An electric cell produces electricity by chemical reactions taking place between the chemicals placed inside the body of the cell. When the chemicals in the electric cell are used up, the electric cell stops producing electricity. Resistors as components that oppose the flow of current. When current flows through a conductor, it offers some obstruction to the flow of current. The obstruction offered to the flow of current by the wire is called its electrical resistance. So, the resistance can be defined as the physical quantity that opposes the flow of current in a conductor. Actually, the flow of current in a wire is due to the drift of electrons. Electrons collide with the atoms of the wire as they move through it. The speed of electrons decreases due to these collisions. Thus, the rate of flow of charge shows and current decreases. Symbolic representation of electrical components. In dealing with electric currents, we can use these symbols. Components, symbols. 1. Electric cell. 2. Battery of two cells. 3. Electric bulb. 4. Key or closed switch. 5. Open switch. 6. Connecting wire. 7. Ammeter. 8. Voltmeter. 9. Resistance. Simple electric circuit. There is a complete pathway for the flow of electric current. This pathway is known as electric circuit. When the electric circuit is complete, only then the bulb in a circuit lights up, otherwise not. Activity. To prove that current can flow only when there is a complete circuit. Take a dry cell, a small torch bulb, and copper connecting wire. Connect the dry cell, the bulb, and the copper wire in a circuit as shown in figure. Leave the gap AB in this. The circuit is not complete, so the bulb does not glow. Now, take a pencil sharpener at both ends and fit in take gap AB. You will find that the bulb glows now. The electric current starts flowing in the circuit. Thus, for an electric current to flow, there must be a complete circuit with no gaps. Circuit diagram. Figure. Electric circuit. 1. series circuit. If all the devices are connected end to end so that the same current flows through each of them, then the combination will be called series combination. In figure, both the bulbs X and Y have same amount of current. If the switch is open, no current will flow and the bulbs stop glowing. Suppose bulb X stops glowing. The circuit will break, hence the bulb Y will also stop glowing. Thus, in series combination, each component depends on the other component. 2. Parallel circuit. If all the devices are connected individually to the source of current, so that there is same potential difference across each device, then the combination will be called parallel combination. In parallel combination, components are independent to each other. Due to this reason, the electrical connection in household circuits are done in parallel. If any appliance becomes faulty, it will not affect the working of the appliances. Battery as a collection of cells connected in series. Battery is made up of two or more cells joined together. In a battery, the positive terminal of one cell is connected to the negative terminal of the next cell. If you connect cells with two positive terminals touching, the circuit will not work. In the same way, a battery will not work if you connect two negative terminals together. Battery usually have positive and negative symbols printed on their compartments to ease identification. The symbols for a battery of 2 cells, 3 cells, or more cells are shown below. Scientist. Thomas Alva Edison was an American inventor, scientist, and businessman who developed many devices that greatly influenced life around the world, including the phonograph, the motion picture camera, and a long-lasting practical electric light bulb. Dubbed the Wizard of Menlo Park by a newspaper reporter, he was one of the first inventors to apply the principles of mass production and large teamwork to the process of invention, and therefore is often credited with the creation of the first industrial research laboratory. Good and bad conductors of electricity. Materials can be divided into two groups: conductors and insulators. Conductors. The materials that allow electric current to pass through them are called conductors. All metals are good conductors of electricity. Carbon, in the form of graphite, is the only non-metal which is a good conductor of electricity. The electric current is conducted through human body also. Impure water is a good conductor of electricity, whereas pure water, distilled water, is not. Insulators. Those materials which do not allow electric current to pass through them are called insulators. Materials such as plastics, rubber, wood, glass, polythene, PVC, etc. are insulators. You might have observed that electrician uses rubber gloves while working with electricity, because rubber is a bad conductor or insulator that protects from electric shock. Activity. To check whether the given material is a conductor or an insulator. Take a dry cell, a small torch bulb, and copper connecting wires. Connect these as shown in figure, leaving a gap AB. With the gap, circuit is not complete and bulb does not glow. Now, take a paper clip and fit it in the gap AB. You will find that the bulb glows. Remove the clip. Now, fit a rubber eraser in the gap. Does the bulb light up? In this way, find out if the bulb lights up using different materials such as paper, copper wire, rubber, aluminium foil, wood, steel, and so on. List out the good conductors and bad conductors of electricity.
Heating effect of electric current. Students, when an electric current is passed through a metallic wire like filament of a bulb or coil of an electric heater, geyser, electric iron, or room heater, the coil becomes hot and glowing. This is known as the heating effect of electric current. In this condition, they radiate heat and light. The amount of heat produced in a wire depends on its material, length, and thickness. Thus, for different requirements, we use wires of different materials and different lengths and thicknesses. Electric fuse. Sometimes you may have seen the situation in your house that the fuse is blown off and the electric supply is cut off. Can you tell the reason for this? This is because of the enormous amount of heat produced wherever there is an excess flow of current due to short-circuiting, overloading or insulation failures of appliances. Safety fuse is a device that protects an electric circuit. The heating effect of electricity is used in this case. When the current drawn is beyond a certain value, the fuse wire gets overheated, melts, and breaks the circuit. This prevents fire and damage to various electrical appliances. Fuses of different kinds are used for different purposes. Plug fuse is used in our houses. The plug fuse consists of two parts, namely, the porcelain casing and the porcelain grip. This fuse has a thin wire of tin and lead alloy, which has low melting point. Cartridge fuse is generally used in electrical appliances. Miniature circuit breaker or MCBs. Miniature circuit breaker or MCB is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by overload or short circuit. Whenever there is a fault in a circuit, MCB interrupts continuity to discontinue electrical flow immediately. It can be reset to resume normal operation. Summary. Let us summarize what we have learned. Electric circuit component symbols are used to make circuit diagrams. The symbols for switch or key, electric cell, battery, and electric bulb are used to represent a circuit diagram. Circuit diagram is simplified representation of an electrical circuit using standardized symbols. When an electric current passes through the filament of a bulb or the coil of an electrical heater, etc., they become hot. An electric fuse is a safety device which prevents the electric circuit from the losses due to short-circuiting or overloading.
Electromagnet. An electromagnet is a temporary magnet formed by inserting a soft iron bar within the current-carrying solenoid. The strength of an electromagnet depends on these factors. A. The number of turns of the wire. B. The amount of current flowing through it. C. The nature of core material. Activity. Making an electromagnet. Wind the wire tightly and uniformly around the pencil. Connect both ends of the battery to the wire. This electromagnet will be strong to affect a compass needle, but too weak to attract anything. Replace pencil with iron nail. Now, you will have an electromagnet strong enough to attract safety pins. Result: the iron nail behaves like an electromagnet. It is called the core of the electromagnet. It will lose its magnetism if the current is turned off. Applications of electromagnets. There are many applications of electromagnets in our daily life. They are used in 1. Electric appliances such as electric bell, electric fan, etc. 2. Steel works and scrap yards. 3. Loading furnaces with iron. 4. By doctors to remove foreign bodies like iron filing. 5. In modern trams and train such as maglev train. Electric bell. One of the applications of electromagnet is the doorbell or an electric bell. Its components are an electromagnet, an armature, a soft iron bar mounted on a string, a contact screw, a gong, and a hammer. 1. When the switch is pressed, the current starts flowing in U-shaped electromagnet and the electromagnet attracts the armature coil of iron. 2. The movement of the iron causes the hammer to hit the gong and the bell rings. 3. After this, the circuit momentarily breaks and current stops flowing. This puts off the magnetic property of electromagnet and the coil returns back to its original position due to spring action of the metallic strip. 4. Armature again touches the screw. The process starts again. Thus, due to making and breaking of current of the electromagnet, the bell rings as long as the key is pressed.